Hello, my name is Jan Matthijs de Meulen and I'm from the company Morphotonics. And in the next discussion, we like to tell more about the topic of large area nano imprinting and discuss the opportunities and the challenges. If you look at displays are a visual product. And if you want to improve the performance, you have to think about optics. For instance, Fresnel lenses, prisms, or bars, wide width polarizers. These are all optical elements which can boost the performance. And then suddenly VR applications become possible with the use of Fresnel lenses, or with slanted gratings enable augmented reality. And lenticulars are used for 3D displays. So all of the optical elements can improve the performance of displays. But the question is, how can you make these optical elements? And especially how you can make them for all kinds of displays, small, large. This is where the work of Morphotonics steps in. So in this presentation, we like to tell a little bit more about Morphotonics. We want to explain large area nanoimprinting, the opportunities and the challenges, and discuss what we can bring to further enhance display performances. The company Morphotonics started in 2014. We saw the need to add textures on larger surfaces. So we developed a scalable imprinting method, which we call large area imprinting, to add the structures on Gen 3 or Gen 5 size, meaning over 1 square meter. So we develop and sell the equipment, and we had the focus on mass manufacturing. We saw the need for an increasing demand for a rapid growing market of nano imprinting, which is there. Currently we have 40 employees. We have our own clean room, and in this clean room we develop the processes together with our customers and for our customers. And you can think of resin developments, basically the imprint process development, but also master upscaling and a flex stamp development and flex stamp manufacturing. We have our own patents. We have more than 20 patent families, of which 5 are currently granted. And most importantly, we have sold already over 20 tools. That means that our equipment is being used, and it's proven. There are commercial products in the market which use our imprinting equipment. And this shows that the work we will discuss today is reduced to practice. It works. So how does it look like? Well, here you can see an animation, and in this animation you can see a stamp is pressed into resin and it's cured, and after the curing the stamp is released or delaminated. So it's cured by UV light, the resin solidifies, and the imprinting process can start again. We can replicate in this manner all kinds of textures. We say any optics. So it can be very small wire width polarizers. It can also be high lenses of 500 microns. And we can replicate this for any display of any size, whether it's a small micro LED or a large OLED panel of over 1 square meter. We can add the textures onto this. We do this with a stamp. The stamp has a longer lifetime of over 1,000 times, and this is where the mass manufacturing steps in. By reusing the stamp over and over, you have rapid cycle times. So below 2 minutes are demonstrated. And the stamp Doesn't mean that the quality is not good. We can replicate very precisely the textures, not only in the replication fidelity itself, but also in the reproducibility. We have confirmed that for over 100 imprints after each other, the dimensional stability is in the lower picometer range. And this is very accurate. We can replicate on glass and foils. Glass starting from a thickness of 0.5 millimeter or thinner with a carrier. And the nice thing is that with this technology you can think of an imprint cost of below $0.50 per smartphone product. And why would you need it? Why would you need large area nano imprinting? What are the opportunities? Well, if you look around, you will see likely more than one display. And a smartphone, a tablet, and the display you're working upon. Every day, on average, people spend more than 7 hours looking at a screen. And, well, you better give it the best visual experience. And it's possible, a lot of new developments are there. So the resolution rapidly increased. So the resolution, we went up to 4K or 8K displays to a resolution which the eye can't distinguish anymore, far beyond what we can see. We have 5G and a very high computational power, which enables all kinds of applications and new applications. Yeah, and you see this in practice in the market. So products like micro and mini LEDs in combination with AR and VR are there, but they are not yet there for the mass market. And then you need further enhancement in the optics and also cost reduction. And both are key to have the best performance for the mass market. And to go there, we believe we can build upon the semicon industry. So they already push for new applications. They're working on meta lenses and wafer level optics, but still on small size. And well, having this background and combining it with display manufacturing thinking, then this would open up new markets for basically all displays. So we strongly believe that a scalable display manufacturing thinking is required, and this is also what we propose. And that would enable different kind of applications. You can think of anti-glare. The anti-glare on a smartphone, by which you can reach your smartphone without increasing the contrast on a sunny day. And although the textures are not too complex, there's not new software development needed. It needs computational power and new thinking in the texture design. It's now possible to go to a combination of different textures, smaller and larger, which gives you complete freedom in design, solving problems like scratch resistance, and going for the best haze and the lowest gloss. Other applications are 3D. Well, there are different 3D applications like multi-view and light field displays, and all benefit from the higher resolution and the higher computational power. And so by both, as well as the 5G bandwidth, 3D really becomes within reach, but you need a large area manufacturing method to add the 3D lenses, to add the 3D optics to the large displays. For AR, the waveguides are still small, and still you need them to be made in high volumes. So you need a method to make them in an affordable manner with highest quality. And this even opens up the opportunity to go to larger sophisticated AR HUDs, for instance in cars. But to come there, you have to go to the complex development cycles, which always starts with the optical design, the mastering, prototyping, and if you're lucky, within one cycle you can start manufacturing, but typically you go first several times to the development loop, after which manufacturing can start, and later on yielding and commercialization. And each of these cycles take time. And if you look, for instance, at the optical design, the more freedom in design you like, the more complex it will get. If you want to combine larger micron textures with smaller nano textures, you need large supercomputers and optical experts to enable these very complex freeform optics. It's not readily available. For the mastering, you have similar complexity. When you go to the smaller textures, you end up in very long mastering times. Therefore, quite often the master is small in size. Luckily, there are new developments like laser ablation methods, laser ablation mastering provided by companies like 4Pico, part of RAID. For the raw materials, there is always a need to develop new materials, especially if you look at glass, going to larger high refractive index glass beyond the wafer scale, Gen 3 or even Gen 5 sizes, preferably with the lowest thickness variation and the highest uniformity. You also need resins, stable resins, which can last long in products without, for instance, yellowing, preferably with a low viscosity. And last but not least, metrology. Metrology and quality control is very important and becomes very complex if you want to detect small micron defects on a large panel, which is even having a diffuse optics or diffuse optical elements hindering you to detect that small defects. And all of these items, they come together, and you cannot solve them yourself, so you have to work together on those. And this is what we did for working on the application of augmented reality. So we worked with the company NILT to provide a master. We worked together with the company SHOT to provide a glass, light trends to provide the design, and OptoFidelity to do the metrology. And then you can think of, once you have the master with the design provided by light trends, then the first step is that you scale up the small waveguide, which is difficult to make, difficult to master, difficult to design, up to a multi-up flex stamp. In this case, we went to a 270 waveguide per flex stamp. So in one imprint cycle, we could replicate the 270 waveguides. And hereafter, you can singulate each of the waveguides out of the glass, and also here the knowledge of SHOT helped. And you can check the quality and finally insert them in the product. And by a company on itself, it's very difficult to demonstrate this. Together, you can make this happen. So what can we do for you? Within Morphotonics we have a long history in replicating a lot of different textures. Basically any optics you can think of. And we did this for small sizes up to 65-inch displays. So we have a scalable technology where which we reduce to practice. As you can see here, you are looking at the Gen 5 plate using an upscaled master. We have the experience of many different applications, each having their own requirements within the materials, within the process settings, and in the upscaling. We have our own clean room and prototyping capabilities where we can work together to show it works, and this is what we do together for our customers. We do this together with a large team, as shown here, and we like to work together with all innovating companies, building new visual experience products and applications. And the innovating companies can be the application developers, but also we look for partners in the ecosystems, material providers, consumable providers, metrology firms, and together we can make it happen. Together we can revolutionize, improve the display, the needed visual experience of displays. So we look forward to discuss this topic in our booth 840 at the Displayweek, or if you have questions or interest in our technology, email us at info@morphotonics.com. Thank you for your attention.